Hello, it is the 11th of March, 2016, and this is episode 46 of the Unseen Podcast. This is your host, Paul Carr, and tonight we are going to talk about Bring Your Own Anomaly. Now, what that means is each of our panelists is going to bring to us what they think is a scientific anomaly, and we're going to sort of break it down, talk about why it's an anomaly, who documented it, what kind of theories have been brought forth to explain the anomaly, why those fail, and why it's still an anomaly. And then each of the panelists will get a chance to express their opinion on the strength of the anomaly. It's kind of a fun game to talk about the things that science doesn't understand quite just yet. Now, there are, in my view, 3 classes of anomaly, and you can weigh in on this in the comments to the show notes at unseenpodcast.com if you want to. In my view, these 3 classes are, the first class is not really an anomaly. We just got the data wrong, or we got the analysis wrong, or we just didn't understand what we were looking at first, but it turns out to be fit perfectly well within existing theory. So not an anomaly. That's class 1. Class 2 is, yes, it really is an anomaly, and after many years of hard work, hopefully we will be able to, or have been able to, fit it into our theories with perhaps a bit of change to the theory, but it didn't really break our paradigm. And the third class is the hard nut anomaly, the toughest anomaly, the one that breaks the paradigm, that makes us change our way of thinking in a radical way. Now, I provided to the team 3 examples. The first example was of an anomaly that wasn't really an anomaly, was the Pioneer anomaly. There they were measuring very carefully. Now, the measurements were correct. They were measuring the velocity and position of the Pioneer spacecraft as it left the solar system. They were finding that the model they had didn't quite fit the data. There was it seemed to be almost an acceleration in the Pioneer spacecraft that had no explanation. It turned out that after more careful analysis, there was an explanation. I won't go into that now, but it was something that was completely within existing theory. The second type of anomaly is one that requires a tweak to the existing theory. And my example for that was the solar neutrino problem, which was a big deal in the 1970s. People were looking at the number of neutrinos coming out of the sun, and it didn't match theory. We fully expect that in the sun, hydrogen is fusing with hydrogen, and that should release neutrinos of a certain type. These are called electron neutrinos. And the best neutrino detectors of the day weren't detecting anywhere near enough neutrinos to match up to that theory. It turned out later, with a lot of work and a lot of analysis and more sophisticated neutrino detectors, that the neutrinos, which are thought to be massless and never changing their type, actually were changing as they moved from the sun to the Earth. About 2/3 of them changed, and they became what are called mu or tau neutrinos. And, right now, there's no satisfactory metaphysical explanation of why there are these 3 types of neutrinos, but we do know that they can change from type. They can change from electron to muon to tau neutrinos. And when we built the detectors that could detect all 3 types, we learned, the sun is producing the right number of neutrinos. So that mystery is solved, but it took some new physics, but not radically new. It was a tweak to the standard model of physics, not a completely new version of it. Now, the third type, is a type of of anomaly that no one can explain and requires not only new physics, but radically new physics to explain. And probably the best example is looking back about 100 years to the anomalies that we had back then. One of them, I'm just going to talk about one, there were actually several that all contributed to this revolution, but one of them was called the black body spectrum. And the thing is, if you heat up a chunk of matter, like iron, for example, heat it up inside an oven so that the temperature is very stable, you'll see light at different wavelengths. And by the 19th century, they were very sophisticated about examining the wavelength of light. And they were using prisms in those days, but they were quite good at it. And what they found was that the spectrum fit a nice curve where it went up and peaked and came back down. But the physics series of the day said, no, we don't understand that spectrum. It shouldn't go up and peak and come back down. It should go up and peak and keep going up. Something called the Rayleigh-Jeans law. Well, a guy named Max Planck came along and said, what if, just what if, light, which is what they were looking at, comes in packets with energy proportional to the wavelength. And when he plugged that into his thinking, and I won't go into the math, of course, but he found that he could match the spectrum of black body radiation, these chunks of iron sitting in an oven, to a very high precision. But that completely revolutionized physics, and along with some other ideas, led to the quantum mechanics revolution. So that's the kind of anomalies we have. Something like the pioneer anomaly, which led to no change in physics or any other theory. The solar neutrino problem, which led to tweaks in the theory, and then the black body and other anomalies that led to completely but completely revising and changing to a new theory that led to what some people would call a paradigm shift. Okay, so that stated, I'm going to ask each panelist to rate the anomaly that is presented as either a non-anomaly, a puzzle-solving anomaly that is a tweak to the current theory, or something that could cause a paradigm shift and take us to a completely new way of thinking. It doesn't have to be a physics anomaly. It could be something else. Okay, so let's start now with our panel. Let's introduce a panel. All these folks have been here before. We have tonight Adam Smith.
Hello from tomorrow.
And we have Ciro Villa.
Yes, good evening from the southern part of the United States.
Marsha Barnhart.
Greetings from beautiful Cadillac, Michigan.
Well, they didn't call it Cadillac for nothing, right? It must be the luxury.
That's right.
Capital luxury. Okay. And Patrick Festa.
Hello again from the Jersey Shore.
And so we'll start with Adam. I don't know, you got a good one, Adam. Give us one of the many that you have in mind.
Okay. I'll start with the large quasar group, which is an anomaly in the night sky found by some astronomers in 2013. It's a group of 73 quasars, all towards the constellation of Leo, that form a line across the universe, something like 1.24 gigaparsecs long, which is a few billion light years. And if it is real, this line of quasars breaks our current understanding of the universe, the cosmological principle that says that everything in the universe should be more or less homogeneous. Whichever direction we look, we should see more or less the same thing. So it was pointed out in 2013 to be an anomaly in astronomy, but there's been quite a lot of debate about that since then. Other astronomers looking at it have concluded that there might not be any clear clustering of these quasars. It may not be a real structure after all, and it is.
Sorry, Adam, are you still there? Adam?
Signals must
We
have
can allow
gone.
a certain amount of randomness in the universe.
Adam, I think we lost you for a moment. Could you repeat that last 20 seconds or so?
Oh dear. I was saying that there are some astronomers that have looked in quite some detail at this large group of quasars just recently, and they think that there's no clear structuring to it. It's just a random chance alignment of galaxies. With quasars are jets coming from the center of supermassive black holes in the middle of galaxies.
Right. Now, yeah. So quasars were once themselves a mystery, right? But we think we know at least roughly what they are. But
yeah, it's where the name comes from. Quasar means quasi-stellar object. You know,
right.
we didn't used to know what they were.
Well, they're very bright, and we know they're very compact, and they tend to be in the center of galaxies. So there's a good reason to believe they're massive black holes. But now, this particular analysis, this was a statistical analysis, right?
Yeah, there was a statistical analysis carried out by a guy called Seshadri Nadathor. He's an Indian astronomer, and he concluded that it's just a statistical chance alignment that you can get. The universe may be homogeneous, but it's not perfect. It's not perfectly random. You will get small clusters of quasars, galaxies, planets, anything, in fact. Just like we can get on Earth in a much smaller way. Things can cluster by chance.
Yeah, we talked
There
earlier.
might actually be some.
Go ahead.
There might actually be some bigger structures anyway. In 2013, this huge, large quasar group was thought to be the very largest object in the universe, potentially. But there are signs that there are other such big structures. There's the Sloan Great Wall, which is a part of a filament of galaxies. And another one called the Hercules Corona Borealis Great Wall is an even bigger structure. So it looks like we can get these huge billion light year long structures and alignments in the local universe. I don't think it really is an anomaly, but it's something that we still don't fully understand.
Yeah. Now, at what point does it get so big that it's a problem for theory? That's that's the question, I guess. Right? I mean, the theorists have assumed that the early universe was more or less homogeneous, and then it expanded out and then started popping out into stars and galaxies. But at some point, if there's gigantic structures, that theory has something to explain that isn't real. I mean, that they haven't explained so far, right? So, how big does something have to be before it becomes an anomaly?
Well, we can't see the whole of the universe, can we? We can only see a finite portion. We see the observable universe,
Right.
which is quite something like 90 billion light years across. So it's a fairly big chunk of space.
Well, and we don't even know if there's anything beyond that or not, right? I mean,
We don't.
The inflationary theory says there is a whole lot beyond that, but inflationary theory is still working on what the observables are for that, right?
Yeah, we can only see as far as the cosmic microwave background.
Coincidentally, the inflationary theory is one of those things that some people, some critics, there are some critics of the inflationary theory that say that it's kind of an artificial construct to explain yet another anomaly. Speaking of anomalies, which is why the universe is so homogeneous, and one of the way to explain that homogeneity of the universe is inflation. But again, there are some scientists that claim that there's still some question marks as what could have caused inflation in the first place.
Well, it's not just homogeneity, right? It's the isotropy, right?
Isotropy, yes.
If you look in different directions, you see the same temperature.
Exactly. Yes. Yes.
Or very nearly the same temperature within, very, very small tolerances. And you have to ask the question, how did it get the same over there as it is over there?
Right.
And with these very slight but quite interesting deviations. And that's one of the embarrassments to the naive theory that inflation tries to answer.
Right. But I think that one of this, and I think that this is a little bit of an epistemological question, if you want, that could cross the boundary between science and philosophy, in my opinion, anyway. Which is a lot of the axioms that are out there, mathematical and physical axioms, sometimes are they explain the universe beautifully, but at the onset, are they put in place because we're trying to fill certain gaps in the knowledge? You know what I mean? It's kind of a little bit of a chicken and an egg question, if you want.
Right. It's a difficult question, and the gaps in the knowledge are exactly where the knowledge comes from, right? I mean,
right.
When we recognize that there's something we don't understand, that's where we learn something new. And now with inflation, or we may get to this later, dark matter.
And dark energy, which is causing acceleration.
Yeah,
apparently.
we have to propose something. We don't know where it came from or what it is exactly, but within the current theory that we have, it seems to fit, and there are lots of good evidence for it. And it's a subject of current research. It's not necessarily something.
But doesn't inflationary theory say that the expansion is at a less rapid rate, and they found that dark energy is causing not a slowing down, but an acceleration?
Well, those two
expansion.
things aren't inconsistent. Inflation says that very early in the universe's history, there was an extremely rapid inflation.
Exactly.
And then, I mean, it went from the size of, smaller than an atom to the size of a grapefruit, or something like that. Yeah,
it was a microfraction of a second when inflation took place.
Yeah, which
it was an enormously small amount of time.
All space and time was inflating faster than the speed of light by a wide margin, and then that stopped. And again, there's different ideas about why it stopped, and then regular expansion took place, and then what we're seeing now could be unrelated to that. So, this is something we're still trying to get a handle on. So I'm sorry, Adam. What anomaly were you talking?
We have hijacked atoms.
Well, it was an anomaly that didn't actually turn out to be an anomaly. Is kind of what you were saying,
I mean,
right?
no, Adam had. I think it's a very interesting anomaly. People have found not only quasars but clusters of gamma ray bursts and things like that. Is that correct, Adam?
Yeah, we're very good at pattern recognition, aren't we? I was
Yes.
thinking about pareidolia and how we can see things, patterns in data that maybe aren't there.
Well, now, when I did see Jesus in that slice of toast, that was real. But
That's not an anomaly, right?
that doesn't count as an anomaly. That is a slice of toast. No, but but Adam's got a good point. We look for patterns in things that may not have a pattern, right? And we do that all the time. That's sort of our built into it, how we think.
So then we have to distinguish when is a pattern not a legitimate pattern, and therein lies the rub.
That is a hard question sometimes, and serious astrophysicists have said, "Look, here looks like this like a pattern of quasars, right, Adam?" And not every astrophysicist agrees that it's a real pattern. Some people think it might be a random pattern.
Yeah, there's the problem of our line of sight. You know, sometimes we see things that look to us they're two-dimensional. The sky's two-dimensional. We see stars, quasars, whatever, without a true sense of the distance. That if you could see something properly in three-dimensional space, that pattern might disappear.
Right, but now, are these quasars all about the same redshift, or are they different? Or
They are about the same redshift. But
so they should be about the same distance.
Not,
yeah,
roughly. But that about can be many, many light years.
Right, I understand. But, you know, when we talk about in the terms of cosmology, we're talking about very wide bands.
Yeah.
So Adam, why don't you size this up for us in terms of an anomaly? What do you think the best case that it really is an anomaly, and what it could imply for us?
There's no firm answer. Either way, it could still be an anomaly. The work that's been done recently would suggest that it's not. It's just a chance alignment that could happen. You know, it might be down to how we see it, or it might just be a random fluctuation in the local universe.
Okay, so I'm going to ask the panel now, starting with Ciro, Marsha, then Patrick, then me. What do you think? How would you rate this first anomaly Adam's brought up? Not anomaly, a minor puzzle, or a paradigm shifter? Start with Ciro.
Yeah, I'm gonna go with. I'm gonna take the middle ground on this one based on what I've heard so far. So it would seem to me like there's a possibility that this might turn out to be not a real anomaly, like Adam was saying. It might be just the way how we are positioned in the universe and how these quasars appear from our vantage point. So and even if they have a certain alignment to them. Again, it could also turn out to be just a random positioning. So I'm a little bit on the middle ground on that one.
Marsha.
Well, I would say that this kind of slides between number 2 and number 3. In my mind, so many things that are being found out in the cosmology can very easily go into being a paradigm shift of our understanding. And so you don't really know enough about this particular one to see if, wow, when we find out more, it's a real paradigm shift of how we see the early universe, or if it's the number 2. So can I go 2.5?
Sure.
Oh, thank you.
Patrick, where does your probability distribution peak?
I'm gonna stay around number 2 because this is one of those needs more research kind of things where it could, everything Adam said about it possibly being a random pattern or an actual grouping. So it's going to be, it's an anomaly that doesn't change any specific, understanding, but it is something that we still don't completely understand until we do a little bit more visual research.
Okay. In my opinion, I'm going to be a little bolder than this peaks at 1. This is probably not an anomaly, but astronomers being fooled by randomness. However, I could be wrong. It happens sometimes. But so it actually be if it is real, then you can skip over number 2. It's a paradigm shifter. We have an inhomogeneity in the universe that we don't have an explanation for. So let's move on to Ciro. Ciro, I think you've got something good for us.
I'm not sure if it's good. It's an interesting phenomenon that has been observed. That it goes into the realm of anomalies just for the very fact that it's not explained to this day, and it's called the Kuiper Cliff. Now, as many of you already know, the Kuiper Belt is that circumstellar disk composed of various small solar system bodies, extending from a distance of about 30 astronomical units. And to remind the audience, 1 astronomical unit is about 9 million miles. So from about 2.7 billion miles, which corresponds to 30 astronomical units, which is also approximately the distance of the orbit of Neptune, approximately, all the way to about 50 astronomical units. This circumstellar disk composed of thousands upon thousands of objects, some as large as dwarf planets like Pluto, and some as tiny as ice particles, exists. Now, the anomaly known as the Kuiper Cliff is the fact that from that particular distance of 50 astronomical units on, the models that the scientists have been calculating predicted that because of the primordial masses required for the formation of Uranus and Neptune should be much larger objects abundant beyond that 50 astronomical unit zone. Coincidentally, that 50 astronomical unit zone, which we don't know if there's a significance to that or not, also corresponds to the 2-to-1 resonance with the planet Neptune. So and from that point on, there's no known observations of these supposed larger objects that, according to the calculation, should exist. Now, there's a couple of explanations that have been suggested. One of them is that there wasn't enough energy for objects to accrete, and therefore they're small and they're not observable. Another somewhat intriguing explanation is that there's very large object beyond that point that could have caused again no other larger objects to be able to accrete together, and for this particular theory, we know that most recently Mike Brown of Caltech, together with another scientist, has announced that this was only a couple of months ago, announced that the prediction are very strong that for the existence of a planet 9. As a matter of fact, Mike Brown was questioned about the Kuiper Cliff by a person on one of his blogs, asking specifically whether or not he believed that one of the reason for the existence of the Kuiper Cliff, which means one of the reasons for the absence of any larger predicted object, was because there's planet 9. And he basically states that it's too premature for him to make a statement either or. I mean, his comment was maybe, maybe not. We haven't figured that out why, but I'd say that there's a 20% that we will suddenly realize what planet 9 is causing. So basically, he's saying, we cannot determine right now whether Planet 9 is the cause of the Kuiper Cliff phenomenon. So those seems to be the two most likely potential explanation, but they haven't been confirmed at this time. So I guess the Kuiper Cliff is still considered an anomaly, an unexplained phenomenon at this point.
Now, the Kuiper Cliff, have we ruled out that it's just not a function of the fact that the greater distance, it's harder to observe those bodies, or?
No, there was actually, it was confirmed that there was not, it seems to be like a pretty clear-cut threshold at the 50 astronomical unit zone where there seems to be a decay in the presence of objects. There's been smaller object observed at a distance of 55 astronomical units, but not the anticipated, at least theoretically anticipated larger objects that were calculated. So there was a recent study, as a matter of fact, that had confirmed the anomaly itself. I don't think that it's a matter of an observational, observational limitation, because it seems to be there seems to be a clear gap, at least a clear line of demarcation between where these objects are no longer Kuiper objects of larger than 100 kilometers in radius are observed.
Okay. So, Ciro, if you are done with that, let's go around and
yes,
get everybody's opinion. Start with Adam again.
We don't know everything about the solar system, do we? I think it's great that we're at last beginning to understand the very outer depths of the solar system. A lot with this one depends on this hypothetical Planet 9, whether it's there or not. If it is there, then it probably is the reason for the Kuiper Cliff. If it's not there, then we have to look for an alternative explanation. So it is an anomaly. So yeah, I'd go with number one.
Not an anomaly, or?
Yeah, an anomaly, yeah.
Oh, it's number two.
Until we get better data.
Okay. All right, Marsha?
Well, if there is the way to determine, scientifically prove that there is this extra gigantic planet that is on this extraordinarily unbelievable orbit, if that is a fact, then that would be kind of shattering. That would be paradigm busting. I think I'd have to go to 3 on that one, I would say. Because that brings up a whole lot of interesting things, I mean, this is woo-woo stuff, but that whole Nibiru planet thing that has been talked about for a long time by the likes of Zacharias Sitchin, which I'm sure you guys are poo-pooing, but that's something this guy and a few others have been talking about for 40, 50 years.
Right.
And so now this anomaly shows up that is getting actual scientists to think, it could be the reason we're seeing this cliff. It might be answered by this gigantic planet that we're calling Planet 9 now.
Yeah, now I'd just like to point out that Nibiru is a planet that comes in close to the inner solar system
at some point,
which we're sure that's not it. So anyway,
do we know the orbit of it? I mean, we don't.
Well, we know the bounds
on
the orbit, and it's not. It stays way out in the outer solar system. It never comes anywhere near. It doesn't come near Saturn, and much less.
Well, how would we know if it had a gigantic elliptical
because it would influence everything else.
30,000 years.
It would be a big influence on other things besides the Kuiper Belt. Anyway, Patrick, what do you think?
Definitely number 2, and I have to say about the Nibiru thing. Nibiru is that fanciful thing where the planet was supposedly opposite the Earth in the same orbit, so it's definitely not Nibiru. But in any case, definitely number 2, because it is an anomaly. It is something that's making us try to. We need more observations. We need more data. So it is definitely falls into the number 2.
Okay, I'm gonna have to agree on that with you, Patrick. It's a number 2. I think the observations are solid. I think that the thing about astronomers is they are the salt of the earth. They're not going to tell you anything that they don't have solid evidence for. So astronomers are like the best natural skeptics on the planet. And that, so yeah, it is a real anomaly. It probably has an explanation that fits well with an existing theory, but what that explanation is, we've yet to find out. It's a puzzle. So it's a puzzle-solving type of anomaly. So number 2. Okay, Marsha, it's your turn.
Okay, now let me open with establishing a point of fact. The process of knowledge filtration. And this is going to build my case because you guys are going to throw me off this damn podcast, I suspect. So if we understand that knowledge filtration is a process that operates in the world of science, and it is like this. Reports of evidence that conform to existing philosophy passes through this filter and is disseminated. But reports that are contrary or radically differ from a particular accepted philosophy will not pass through the filter. Ergo, they are not dismissed. They will then not accumulate in the body of science and therefore will not be considered as evidence. So, taking that into account, I want to talk about what I think would be a paradigm shift anomaly in the area of paleontology and archaeology. And that is multiple anomalies that have, if you put them in one big box, would lead one, if they kept their mind open and looked at all the evidence, that which was not secreted away, proven to be secreted away, one might be led to the idea that humankind is far, far, far more ancient than is believed today in mainstream archaeology and paleontology. And that is what I'm bringing up. I think that we know that scientists from antiquity have cheated on a very large scale, depending upon their religious philosophy or what have you. We know that textbooks are inaccurate in many cases. And I think
Marsha, slow down a bit. Okay,
yes.
You said that scientists have cheated in antiquity, but I mean, is your claim that scientists cheat in general, or
yes? Okay. I would claim that scientists cheat because, whether knowingly or not, because they will not allow particular information that does not conform with the scientific philosophy of the day to get through the knowledge filter. And they knowingly do that because anomalous things are not fitting in and conforming with how they think things have been. And so my feeling is that we have evidence that has been swept under the rug that tells us human evolution, abundant evidence about human evolution has been ignored.
When you say evidence, evidence of what?
Evidence, for example, of, let's say, now there was a dig in 1980 in Mexico, and a lady from a museum, not a museum, a university, had this dig, and they found in the strata that had been dated to 250,000 years ago these tools that had been obviously made by very adroit human hands. And those that came in and did tests on the strata agreed that it was 250,000 years old, but they were not going to release the test because it did not conform to what was known in science then. And they just wouldn't do it because they would not go on record as agreeing to that being the age of these findings. That and multiple other ones. I mean, I'll give you.
Well, how is it we come to know of that then if they didn't release it?
Well, because the woman who did this dig, the professor who did this dig, that said, okay, well then, to hell with you guys. I will publish the results myself.
Oh, so she did publish it anyway. Okay.
She published it. She self-published it, but the university would not let her because they didn't want that kind of information out.
Do we have a publication then?
Yes.
Okay, so let's put a link to it in the show notes. And
all right, I'll get that info to you. Now, and you know, back in '79, Mary Leakey discovered footprints that she said, and others agreed until they dated it, that was indistinguishable from modern human footprints. She found that at Laeti in Tanzania, where they'd done a lot of digs. Now, these footprints were found in solidified volcanic ash that was dated to be over 3,700,000 years old. That got just disappeared. So I would say, now this is just one or two. I can assure you, gentlemen, that there is an abundance of what is called the primary type of information. You know, you've got secondary information like textbook and stuff, literature, where things have been kind of diffused and put into bite-sized bits, secondary type of literature. But primary literature, which are reports and studies published in professional scientific journals and periodicals by the actual science investigator who undertook that, there are plenty of examples of primary literature that holds this type of evidence, but it is not being diffused. And I think it's because the knowledge filtration is not going to allow it. And we can argue till the cows come home about this.
Well,
but
okay,
that's what I'm setting forth
what's the framework here? What is the claim?
The claim is that there are multiple anomalous archaeological finds that do not conform to how old current science feels human beings have been operating on this earth, and that they are millions of years off. And my premise is that it's being withheld for whatever reason.
Okay,
that's my premise.
Withheld by a conspiracy, or
withheld by the scientific community, the same scientific community that, you know, well, let's say way back in the day when religious philosophy would not conform to the fact that the earth revolved around the sun and ergo it didn't. That was an early example of no, it doesn't. So that type of thing.
Okay.
And I know most scientists don't want to believe that, but you know very well, and remember you were talking about Gita and such, talking about how science has some real problems they have not addressed, and this might be one of them.
Okay. Let's start with Adam. What do you think? Is this 1, 2, or 3?
I would give this one a 1. No, it's not an anomaly. I can't believe that there's this huge conspiracy of paleontologists in the world secretly trying to, dismiss scientific knowledge. If there is, scientists work to try and disprove theories and evolve their theories. They're constantly trying to push back the barriers of our understanding. Why would they suddenly think, oh,
I would
no,
admit
let's stick
that's
with
true.
our old theory because it's nice and cozy. We like this one.
When
Science doesn't work like that.
Yet when science is functional, it doesn't work like that. But when science is not functional or dysfunctional, then it doesn't work like that.
Okay, let's move on to Ciro.
Okay, so just very very quickly, premise that let me make a premise that I'm always very open-minded about even the most fringe theories or speculations in general. But for this particular case, this is how I see it. I think that the age of humans, of the appearance of humans on Earth, is still subject to debate. As a matter of fact, I just during the time of this conversation, I found an article stating that there was some recent research that found that humans were 500,000 years, appeared on Earth 500,000 years before what was previously known. So my point is that I think that there's a scientific argument that opens discoveries to new facts. I'm a little bit less inclined to believe that there's a conspiracy that wants to hide these new facts coming to the surface. I think that to the contrary, if there was something like this discovered, I would think that there would be a movement trying to maybe confirm those findings and maybe become a paradigm shift if those were confirmed. So I guess that's how I look at things myself. I don't know if it makes sense or not, but
no, I understand exactly what you're saying. Yes,
Okay, Patrick.
I don't know.
Patrick.
That's my opinion.
Patrick, how about you?
Yeah, I have to agree with Ciro. Maybe a little bit harsher note. The types of reports that you speak of are those types of reports that are in the hyperbola realm of conspiracy mongers. They'll say that there's been footprints found that dated 3 million years old, and we don't really know that. I mean, where did that come from? In other words, I can't even rate this a 1 through 3 because the anomaly you're talking about is an anomaly of anomalies. It's sort of self-repetitive or something. There is, of course, the idea that scientists will get together and not agree on something, therefore they cannot allow it to be published until they can come up with some kind of firm consensus as to what the actual data says. Not to publish something that is full of holes or questions is not the way science is done. Therefore, if you're talking about those kind of reports not being published or not going through the filter, it's because that they are not well, calculated or figured out, or there's just something so far from it. There's something wrong, and they have to really understand what the heck is going on. But the way you're putting it, it sounds to me like, a conspiracy theory. So, I mean, on a scale from 1 to 3, it would be a 3+. It would be in the realm of hyperbola.
Yeah, I didn't say conspiracy theory. I just premised this on knowledge filtration. It's just a real common human thing. Knowledge filtration almost takes place without people thinking.
I use the word conspiracy theory because that's where conspiracy theories come from. They come from the face on Mars. It was another. NASA is hiding something, and scientists are hiding something. They don't want to tell you that this alien place really existed, or these are types. Now, of course, what you said was completely less than that. It was less fantastic than that. But yeah, and humankind has been, the dates of the humankind has been being pushed back to the point where there are human-like more than 1 million years. But certainly not identical footprints in lava, ash, mud, that dates back millions of years. That just doesn't work that way. I mean, they might have dated the actual substance to be that old because the Earth is actually a lot older than that, but the footprints themselves it's just, you know what I'm trying to say. In other words, this is where conspiracy theories come from.
Right. You're doubting the evidence that was presented to you.
Right, because I didn't actually
And that's
see the
fine. And
report.
you can doubt that evidence presented to you. And that's common. People are going to doubt evidence presented that they just cannot believe in. And if this were factual, then that would change the face of archaeology, if it were.
Yes, it would. It's a big change. It would be a 3. But like I said, I didn't see the report. In other words, I would have to see the evidence. I would have to say, well, what are you talking about? Is this really dated? Was the dating done properly? Was the method used proper?
Right. Yeah.
That's, in other words, I don't know anything about it. You're just tossing it out there and saying that this was found, and they filtered it out, and the university refused to publish it. And I can't just jump on that. Oh my God, they did? No, I don't think so. I have to see what you're talking about.
Okay. Well, here's my turn. I think to a certain extent, Marsha's onto something, that we do have cognitive biases, and even very smart, sophisticated people have cognitive biases. Even I have cognitive biases, although they're not significant. And scientific paradigms are biased toward rejecting data that is way, way, way outside what they're trying to look for. But the other side of that coin is that people who understand the data very, very well from within a paradigm have extremely sensitive anomaly detectors. When something isn't right, they will be the first ones to recognize it, not the last ones. So I think that although I don't know exactly what Marsha's talking about in terms of these anomalies, in any given field, there's lots of mistakes made. And, we've all made enormous blunders in interpreting data, at least those of us who get paid for interpreting data. And those blunders come from a number of sources. Sometimes it's just that we thought the procedure was correct and it wasn't. We trusted someone to get something right and they didn't. Or we trusted ourselves to get something right and we didn't. So I'm going to put this probably category 1, not an anomaly, but I'm going to skip over category 2. If Marsha's right about these anomalies, then it is a paradigm shifter. I think there's a huge amount of evidence for the standard model of human evolution, which is that about 100,000 years ago, give or take, maybe more like 200,000 years ago, is when the first human populations existed. Evolved from probably Homo erectus that existed about 1 million years ago. And Homo erectus actually did a lot of the hard work. They evolved things like fire and walking upright and cooking and so forth. And there's still a lot of work to be done on the details of human evolution, from going back to even 5 million years ago when we were indistinguishable from chimpanzees, or the ancestors of modern chimpanzees. And that whole history is very difficult to study because there's extremely sparse fossil record. Because in Africa, it's hard to leave fossils. If you die in a forest, a jungle, your bones are almost certainly not going to be preserved because the acid in the soil will eat them right up. The ants and the other animals will eat everything else. So the fossil record is extremely sparse, and it'll be a long time before we really have the whole story. I think there's hope that we will get the whole story at some point. So I'm going to say 1, maybe a 3, maybe a 5% chance that these anomalies are true, and it would shift the paradigm. It would say that our species is a whole lot older than we think it is, but right now I think the weight of the evidence is on the standard model. Okay, Patrick, your turn for an anomaly.
Well, it was a change from the space stuff, but I got another space one for you. The the anomaly that they had discovered, the Mars reconnaissance orbiter had followed seasonally these what looked like, and still may be moisture, but what looked like flowing water on the hills of Mars, somewhere on the mountains, and it seemed to be changing seasonally. So when it got warm, when the sun hit it, it seemed like there was these trails that looked like water flow. They had a few hypotheses on how it might be. I think, I'm not positive, but I think they discovered that there was actually loose dirt flowing. But they took a closer look at some other places with the rover, and they did actually find, when the sun rose, there was actually a very salty kind of water literally seeping in the dirt. So there does look like there's actual water flow, but it's not water flow as you would think of it. It's more of this coloring of the dirt with moisture behind it. It's not water that you could drink, but it's moisture. So they think that it could be that. It could be the similar things on the sides of the mountains, frozen moisture in the dirt could be getting warmed up enough to suddenly cause these water flowing look like water flow trails. Again, it's not the water that we could drink. It's in fact, if it does become actually wet, it immediately evaporates because of the thin atmosphere, it boils away. But it seems to be a cycle, and this was a highly exciting anomaly that they found. And with a little research, I think they have the answer, but it may still be questionable. But it certainly got the scientists in an uproar, loving the idea that Mars might have water in it and stuff like that. Certainly, sooner after that, they revised their ideas of how Mars was so many billion years ago, and they now are pretty sure that Mars was in fact once a green, wet planet like we are, at one time. Not necessarily with creatures walking around on it, but we don't know that yet. But certainly not the desert that it is now. So I don't know if I call that a 1 or a 2, but
well, let's get the panel to weigh in. What about you, Adam?
I think Patrick's talking about recurring slope linear on the.
Well, there was one particular puddle they saw, or the remnants of a puddle.
Yeah, well, both. The recurring linear slope linears. Yeah, that's the word.
I think it's now we're now pretty sure that they are caused by water. It's not fresh water though. It's very briny, salty water. The Martian soil is very salty. It's got perchlorates in it, which are pretty nasty.
Right. Even though the temperature is still way below, zero, it was melting because of the saltiness, like throwing salt on your icy driveway.
They appear seasonally, like you say, on the sun-facing sides of cliffs. So it's something that used to be an anomaly that we didn't fully understand a few years ago, but we have now got a fairly good handle on what causes them. And the European Space Agency is sending its trace gas orbiter to Mars in a few days' time. On Monday, I think it launches, and that's going to have a camera on it that's going to look at these recurring slope linear in some more detail. So it's a work in progress, but I wouldn't say now it's an anomaly, because it's something that we do understand.
So that's a 1?
Yeah, I'd say it's a 1. Okay. What about you, Ciro?
Yeah, I'm going to have to agree with Adam on this one. It seems to me like more and more in recent years there's been mounting evidence of the presence of one point or another in history of water on the planet Mars. So, in this case, although it was, these features were pretty striking and surprising when first discovered, the fact that they demonstrate the presence of a certain amount of flowing water, it kind of, I don't want to say it was necessarily, fully anticipated, but it wasn't as much as a surprise as it would have been perhaps a decade ago. So I would tend to say that this would probably a non-anomaly in that sense. So I guess I would have kind of agree with the 1 rating on this one.
Okay, Marsha, your turn.
Yeah, I'd say it was a 1, and I'd say Patrick pretty much presented it as that. It was something that was an anomalous finding early on, but once you got to poking around and once we put as much together as we knew, it was determined to be, we shouldn't be too shocked that there's water there that we can observe. So a 1.
Okay. My view is that it's also a 1. We expected there to be ice and other volatiles under the surface of Mars. From time to time, they will poke out and turn into liquid and then disappear. The interesting thing is that we now have the capability to observe that happening, not quite in real time, but almost in real time on the surface of Mars. Now, I'm going to point out, Mars is mostly an extremely dry, extremely dead surface right now. It's not a planet that's thriving with all kinds of activity. However, we think that sometime in the past it may have been. So that's really the big questions about Mars right now are what did Mars used to be like? Not so much what it is now, because right now it's not very dynamic. It's mostly wind erosion that shapes the surface, and as David Grinspoon pointed out to me when I talked to him about Mars, he said, Mars doesn't look like a planet that's alive. Earth looks like a planet that's alive. You can tell there's a big difference. There may be a small amount of life clinging to its existence on Mars right now, but just clinging by its virtual toenails.
Probably extremophiles.
Extremophiles that are just barely hanging in there. Because Mars has very little liquid water flowing on the surface or even underground. Now, the good news is there is water there. It's frozen mostly, but if we can get to it, we can make a living off of that water. So that goes back to our discussion with the Mars One candidates and others about how we would live on Mars. I think we may have a future episode about that as well. Bring Ryan back and let's talk about that. So that's a good one, Patrick, but I think it's not a huge anomaly. Now, what I'm going to
good. That's all I know.
Okay. Well, my anomaly is a little bit of a weirder one, but it's based on solid scientific data, and I really don't know what the answer is, and I'm not going to propose an answer. It's just an anomaly. It's a weird thing, and it has to do with something that happened as humans, that's us clever apes here on this planet, started to get good with radio. Now, radio in the early days took a lot of skill to even the most basic radio. You had to be pretty clever to build a radio back in the 1920s. But even then, there were amateur radio operators who enjoyed doing that sort of thing. Even to this day, there are people who are what they call ham radio operators who build their own radios, build their own transmitters and receivers and everything. And some of them, or you can buy the stuff off the shelf. Today, there's a whole movement towards what people call makers, people who build their own electronics or whatever they build from components that are available or from from things they make themselves. Although with today's level of technology, you really can't make it all yourself. You kind of have to piece it together out of components and chips that are available. So back in the 1920s, there were some really clever folks who built their own radios. This must have been very exciting and very edgy in those days because that was brand new stuff. It's almost like building a rocket to the moon now. And there was a fellow named Jørgen Hals who lived in Norway, and he found that when he sent out some transmissions on his amateur radio, that they came back to him later, the same transmission. It wasn't somebody transmitting it back. As far as he knew, it was the same thing he sent out. And this was in 1927. And so this was between the First World War and the Second World War, and just before the Great Depression started. And he brought this to the attention of professional scientists. And there was a fellow named van der Pol, who was a Norwegian scientist of very high reputation, who got involved. And they started measuring these echoes, what they call long delay echoes. Now, every amateur radio operator knows that if you can send out a signal, you get you can get an echo pretty quickly, well under a second. But these were 3 seconds, which made no sense. And then they started trying to see how many echoes they could get. And they got as high as 260 seconds, which made no sense. These were just like sending out Morse code signals and hearing them come back. Now, if you bounce it off the moon, it'll be back in less than 3 seconds. So, it doesn't make sense it would take 260 seconds. Now, then there was a war, as you might know, and then during that war, amateur radio operators got involved in supporting their various nations' war efforts. But then after the war, they got back interested in the long delay echoes, and they started making more observations of them. And in 1960, a Stanford scientist named Ronald Bracewell proposed that the long delay echoes might actually be coming from an alien probe. He wasn't too sure about that, and he was never actually, through his career, never sure about that. But back in the 60s and 70s, there was a lot of interest on this. There's a very good summary paper by Volker Grossman that I will leave a link to in the show notes. Amateurs reported long delay echoes in the 1960s, the delays up to 10 seconds, were still very long. And then Stanford University got involved in the late 60s, and they recorded several long delay echoes. And by 1971, they had seen one as long as 31 seconds. We know two things about the LDEs, the long delay echoes. They are not reflections from astronomical bodies, and they are not echoes from man-made satellites. Beyond that, we don't know what they are. We can't really justify jumping to any conclusions. Now, there was a fellow in Scotland named Duncan Lunan who did a lot of analysis of this. I like Duncan and I respect him. I don't think I quite agree with his analysis, but he actually found a pattern in that there seemed to be a message. I'm not sure I agree with Duncan that it was a message, but he seemed to think it was associated with a particular star. To this day, we don't really know what the long delay echoes are, and to my knowledge, there's not a lot of people following up on these observations. These frequencies that these were observed at were lower frequencies that amateurs used to spend a lot of time on. That these days they're not as interested in those lower frequencies. They're up in the shorter wavelengths, higher frequencies. So there have been a lot of efforts to theoretically explain the long delay echoes in terms of the Earth's magnetic field. None of those have been completely successful. Perhaps a few of them, few of the long delay echo observations have been explained possibly as plasma phenomena in near the Earth, but not all of them. So this is a well-documented phenomenon. There's no explanation, and I'm going to turn it over to the panel now, and I hope you understood what I just said. And let's start with Adam.
Yeah, it's an interesting one. I was thinking about could a signal echo through the Earth's atmosphere, echo back down to the surface, or loop around through magnetic fields. You've got the magnetic fields of the sun as well, which are a lot stronger. It's something that's unexplained, but it's not something that's unexplainable. I guess it's something that we may well find an answer to one day. But for the moment, yeah, it's an anomaly. Congratulations.
So 1, 2, or 3, do you think?
I would give it.
It sounds like you think it's a 2.
Yeah.
Yeah.
Okay, Ciro.
I hate to sound like an echo here, but I would probably go with between a 2 and a 3 on this one. Coincidentally, I semi-cheated, so to speak, while you were speaking, Paul, and I was looking at the long delay echo just to go ahead and inform myself a little bit about it. And I noticed that one of the there was somebody that even suggested that there might be deceptions, there might be hoaxes, which would be an interesting turn of events. Obviously, if that would be found out at some point, but apparently somebody believes that there's that possibility to be considered. So yeah, obviously, if it's it could potentially be a paradigm shift if it turns out to be a real phenomenon, and if the explanation of the phenomenon is found, it might be something really interesting. So I would go probably between a 2 and a 3 on this one.
Okay, Marsha, how about you?
Well, Paul, I got to tell you, I thought mine was out there. But your anomaly, that really is fascinating. And yes, if what you presented is factual and there is no hoax, and that this phenomenon is still ongoing, but people just aren't going there because for whatever reason, and if it turns out to not have some prosaic answer, then I would say if this Bracewell guy happened to think somehow aliens were involved in this feedback thing, then I would have to give you a number 3 there, dude.
Okay.
That's a paradigm shift.
Okay, Patrick, how about you?
I'm going to go with a 2 because I don't know where the information is, but I think it was 25 years ago I was looking into signal propagation and stuff. And many strange things can happen with radio signals, especially, for example, ham radio operators and even CB operators at the time would used to love to skip signals, and they would talk to people halfway around the world just in time with the solar activity. In fact, there's a website that follows the solar activity. When the solar activity is highest is when you can bounce signals off the ionosphere all over the world. I'd like to think that I would have an explanation. I don't have any scientific ability to prove it, but I would like to think that it's very possible that a signal can do a bouncing around and then finally somehow find a hole in the ionosphere and shoot back down to the ground, and you can hear the echo 200 seconds later. I would think that was a reasonable explanation. I don't think it has any wushu. I don't think there's any aliens or anything like that. There's a decent explanation for it, and I think the possibility of bouncing back and forth in the atmosphere until it finally finds its way back down again is a reasonable hypothesis as to how it might be that long duration.
Okay.
So we'll go with number 2.
My own assessment, having looked at this in some depth, is that it's somewhere between a 2 and a 3, like Ciro said. It's possible we could find a physical explanation for it, but attempts so far have failed by some pretty clever people. And so the third one number 3 category is something completely different. We don't know what it is. I don't know that it's a Bracewell probe, but we don't know. I mean, we just simply don't know. And when you have something that doesn't fit any explanation, you're not justified in inventing something necessarily. You have to go and find some more information about it. And I'm really hoping that we can get some more data on long delay echo, some modern data. But I think that the fact that this persisted over more than 40 years and many incidents is evidence that it's not a hoax. And so it's something real. It's not something in the ionosphere. That would be much shorter duration. So we don't know what it is. And when you don't know what something is, the thing to do is admit you don't know what it is and try to get more information rather than invent some supernatural entity or whatever it is that is causing it. Could it be a Bracewell probe? Maybe, but we don't have any direct evidence of Bracewell probes. And if we had more time, I'd bring up 1991 VG, but that's a pretty weak anomaly in my view. So I've kept it on the shelf for now. Okay, we are well over an hour now, and so maybe I think we'll probably go around one more time. Everybody give their final thoughts and recommendations, and then we'll wrap it up. So let's start with Adam.
I was just thinking that your anomaly, Paul, reminds me a bit of the music that the Apollo astronauts heard on the far side of the moon. Was it the Apollo 8 astronauts that were traveling around the far side of the moon, and they heard, I
think it was Apollo 10
noises on their radio?
Apollo 10 was where they heard
Apollo
that.
10, yeah, sorry. Apollo 10, yeah, sorry.
I think we know what that was,
weird...
but yeah.
Which coincidentally popped back into the news in the last couple of weeks.
Yeah.
If I'm not mistaken.
Only because History Channel decided to bring it up on television. It had nothing to do with. It was nothing new, really.
No, it's an unexplained radio signal that could be coming from anywhere, really. Could be coming from Jupiter. Who knows? It's coming from somewhere.
Well, it could be coming from Saturn. That's where Sun Ra was from. But sometime I'll tell you about Sun Ra. My recommendation for this week, I'd like to recommend people visit Cosmoquest. And do some more citizen science with Cosmoquest. Yeah, there was a big announcement about that.
They've had a big. They've been allocated a big grant by NASA, so they're going ahead with lots of new science projects, which is good. Yeah,
well done, Pamela Gay. I think she led that.
Yeah.
She did a good job. Congratulations, University of Illinois, and is it Illinois? I think it is Illinois, and
Southern Illinois, yeah.
And Pamela and Dr. Pamela Gay. Well done, Ciro.
Yeah. So in conclusion, first of all, assuming that there's still an audience left at this point, I think that to be able to explain a lot of these anomalies, we're definitely going to need more cowbells. So,
well, that goes without saying. I mean, that's like we need more oxygen to breathe. You know,
that's becoming our team. I mean, there's a lot of anomalies out there, a lot of unexplained things. I think that in time, science is going to progress. A lot of things are going to be, explained. And some things are, some new things are going to come to the surface. I mean, that's how things work. I think that for recommendation this week, I have found this absolutely beautiful and really remarkable, in my opinion, visualization / poster by a Slovakian graduate student and graphic artist. His name is Martin Varzik. And I have a web address that I will definitely provide you, Paul, for the show notes. But this poster, it's a poster of exoplanets, and it's a visualization showing more than 500 exoplanets discovered before October of 2015. And at the time, it was about a fourth of all the exoplanets confirmed. And on this visualization, they're arranged according to their temperature and density. And the peculiar thing about it, it's that also the solar systems planets are included. So one can actually do a comparison of the sizes and the densities and the temperatures of the different planets of the solar system with these other 500 planets that were discovered. But it's an incredible piece of artwork, though. So I strongly recommend viewing it.
Okay. Marsha, how about you?
Well, my recommendation would be to read the book Forbidden Archaeology by Michael Cremo. It's a scholarly work, and it's very heavy on footnotes and links and information that I think most readers would very much enjoy. Michael Cremo, Forbidden Archaeology.
Okay. And finally, well, not finally, but Patrick.
Well, in the spirit of my ever quest to improve the scientific literacy of this country, I discovered on my way to go do food shopping because I listen to NPR radio, that they actually have a kids science podcast, and it's called Brains On. And I'm listening to the radio, and I came home after food shopping, and I right away went to my computer and typed in Brains On the Google. And sure enough, I was able to listen to 1 or 2 episodes. It's very cute, very, very good. I mean, these kids were 5 and 6 years old, and some of them were 10. But it's a science. It's designed to bring science literacy into children, and it really is a wonderful thing. For one thing, it's not something that in other words, if you're a parent and you're on your way to take them to soccer practice or some long trip or something, it's not something that you have to put on YouTube and then you don't know where they're looking anymore while you're driving. It's a podcast that you can listen to together and have fun while you're driving or whatever it is. You could do a family night thing during a starry night, or something to that effect. It's very cute, very, very well done, and I just realized it was actually from the people of NPR. So it's called Brains On. And I think it's brainson.com or .org. Well, just type in Brains On and you'll find it.
James actually recommended that last week. James that has young children.
I didn't know that.
Yeah.
Sorry.
Okay, my turn. Well, it's been fun going over some what I think are a small subset of the interesting anomalies. I want everybody to just recognize, and I think any real scientist will tell you science doesn't know everything, and that there are puzzles and questions that we face. Most scientists will tell you that the open questions within their field are puzzles that they have to solve and fit within their field, but some are broad-minded enough to know that they may not fit everything in, that they may have to shift paradigms. But since we know about paradigm shifts now, since Thomas Kuhn in the 1950s and 60s, that people are always thinking in those terms, and perhaps shifts are more subtle now. If you look at how astronomy has ridden out the waves of many, many changes over the last 50 years without really throwing out very much, it's been remarkable. And I think maybe somebody should write the history of that. Not me, somebody else, somebody with more patience and industry than I have. But yeah, it's been fun. And I think we'll probably do this about once a year. We'll go over, if the podcast continues to persevere. I would like to point out, I'll point out some stuff in my final remarks, but the podcast is doing well. So, except in the area of acquiring new panelists, and that's something that I would like to do better on. But my recommendation is a book. I think I've done enough music and podcasts for now. I'm going to do a book, and the book is a book that I think is relevant to what we've talked about tonight. A guy who forced a paradigm shift, even though it didn't happen in his lifetime. This gentleman's name was James Hutton. He was a farmer and a doctor, and he lived in the 18th century in Scotland during the Scottish Enlightenment, which was a very important time in human history. And Dr. Hutton, while he was farming, figured out that the Earth was far, far older than the standard model of the time, which was 6,000 years. And he actually found geological evidence of that and published it and produced some lectures in Edinburgh. It didn't make a big impact at the time, but a small number of very smart people were aware of Hutton's work, and it eventually became part of Charles Lyell's thinking. And of course, Charles Lyell changed the world through his influence on Charles Darwin. So I had to add that about Charles Lyell, wasn't it? Well, I'll check that. I guarantee I'll get one fact wrong per episode. But anyway, it's called The Man Who Found Time, James Hutton and the Discovery of the Earth's Antiquity. It's written by Jack Repchek, and it's a very good and not very long book about this remarkable human being who realized, possibly for the first time, that the Earth was at least millions of years old. Of course, at the time he didn't have the tools to determine how old it was, but it was an amazing revolution in thought that went on during the Enlightenment, and it's a great story. So that's my recommendation. Now, a couple of notes I'd like to make. First of all, yes, we are doing very well in terms of audience growth. We are not doing very well in terms of panelist growth. If you would like to be on the panel, or if you just think you might like to be on the panel, and we're not looking for people to be on every Friday night. We're looking for people to be on 4 or 5 times a year, maybe once every 2 months. Please feel free to email me at unseenpodcast@gmail.com. I will tell you exactly what you need to be on. As you can see, you don't have to be particularly good looking, but it helps if you are, you have some thoughts, you have some burning questions about important and interesting issues of the day. It doesn't have to be about space or science. It could be about biology or history or politics or anything else. And there's no particular topic that's off limits except for possibly the private lives of celebrities and sports. And that's what I'm talking about the Barclay Premier League. Maybe we'll talk about that sometime. But the thing I'm trying to get at is that anyone can participate on the panel. You don't have to be as clever as Patrick. You can be. You don't have to be an expert in a particular subject. You just have to be. Have a lot of questions, have a lot of interest in the subjects that we cover. We try to cover interesting, cool things about the future of humanity, about the universe, life, everything. That leads me to remind you, as I did last week, soon we're going to do a Douglas Adams episode in May, and by the way, May is coming soon. That's good news for many of us. May is one of my favorite months, and one of the things we do in May is Towel Day, which is a celebration of the life and work of Douglas Adams, and we will have an episode that will be the celebration of the life and work of Douglas Adams. If you want to be on that panel and no other, again, unseenpodcast@gmail.com. So another thing I'd like to say is that we are somewhat modifying the way we do business in terms of coming up with topics. If you're in the Unseen Podcast panel pool, that is, you're a member of the Unseen Podcast community on Google+, I just posted something about how we will proceed. We have a 4-week cycle. Early on, we throw out the ideas that will become part of the the topic for the podcast. And then as we proceed through those 4 weeks, we get more refined, more detailed, and we stop throwing out random ideas and we start working on converging on a topic. And I've written something up about that. Hopefully it won't be that confusing. And the host for that episode, which won't always be me. In fact, James is scheduled to be on the April 1st host, because I may be away with my children doing something for spring break. Maybe I'll come down and move into Ciro's house for a couple of days. Or Mike Mongo's house in Key West. We'll have but we may not be here. So James who will be suffering through tornado season in Oklahoma, will host, and James will be in charge of what the topic is that week. And so by all means, enjoy. We enjoy having you on. If you're a listener, you're probably already qualified to be a panelist. And by qualified, I mean you're interested in the subject matter that we talk about. So the other thing I wanted to mention is the Wow Signal, which is the parent podcast of the Unseen podcast, has had some new material out recently. But please go to wowsignalpodcast.com. I put out something called the Tabby Star for the Perplexed Part 1. We've talked about Tabby Star on this podcast a few times. That's a star that shows anomalous dips in its light curve. And so I try to put something together for people who are not astronomers, can understand what's going on there. That's Part 1. There's going to be a Part 2 and probably a Part 3, maybe even a Part 4. Also, Nick Nielsen put out something recently called SETI, about SETI, and he's going to do another one. We'll have another one from him out soon called the social context of SETI. And so, and Nick drops me a bit of content for the Wow Signal about once a month. So stay tuned for that. Go to wowsignalpodcast.com to learn more. And I really hope we'll have a very important interview in April with an important scientist involved in Tabby Star. But that's not set yet, so I'm not going to claim it. But if you have questions about Tabby Star, please feel free to forward them to me at wowsignalpodcast@gmail.com. And also, if you are interested in the Fast Radio Burst we talked about last week, which has been a very popular episode, please, if you have questions or comments or factual information or something new about that, shoot me an email at either unseenpodcast@gmail.com or wowsignalpodcast@gmail.com. We'd love to hear from you anyway. We want to hear your comments, your questions, your criticisms. If we made a factual error today, let us know. And we'd also love to have you over in Google Plus to discuss our topics and everything else like that. So come on. We have both a listeners community and a participants community. We also have a listeners community on Reddit. Unseen Listeners is the name of the subreddit. So, and Mateusz Macias has put together a page on Facebook that you can comment on. There's no end of social media outlets. You can follow us on Twitter at Podcast Unseen. And we'd love to hear from you there, and hope you'll follow us. And if you're not a spammer or a cute Asian girl, we will follow you back. So that's pretty much it for tonight. I'd like to thank my panel, Adam Smith.
Yeah, thanks, Paul. Pleasure.
Ciro Villa.
Yes, thank you so much for allowing me to be on the show again, Paul. Have a good evening.
Marsha Barnhart.
Thanks a lot. Had another good time.
And Patrick Festa.
As always, it's a pleasure.
And this has been episode 46 of the Unseen Podcast. We'll see you next week for episode 47. The topic's not set yet. Why don't you shoot us an email or a comment and let us know what you think it should be about. Okay. Good night. We'll see you again next week.